Welcome to the world of number theory and mathematics. In this video, we will explore some fundamental concepts in number theory, which is a branch of mathematics that deals with the properties and relationships of numbers, especially integers. The main topics that we will be covering include greatest common divisor, also known as GCD, least common multiple, or LCM, prime factorization, and modular arithmetic. Let us begin this exciting journey into the world of numbers. Let's start with the greatest common divisor, often abbreviated as GCD. It involves finding the largest positive integer that divides two numbers. So, what exactly is the greatest common divisor? By definition, the GCD of two or more integers is the largest positive integer that divides each of the given integers without leaving a remainder. For example, the GCD of 12 and 18 is 6, because 6 is the largest number that divides both 12 and 18 evenly. Now, let's explore the applications and properties of the greatest common divisor. GCD has several practical applications. It is used in simplifying fractions to their lowest terms, finding the least common multiple, solving Diophantine equations, and it even plays a role in cryptography, specifically in the RSA algorithm. One important property is Bezout's identity. For any integers n b with GCD equal v, there exist integers x and y such that a times x plus b times y equals. This means we can express the greatest common divisor as a linear combination of the original numbers. Now let's move on to the least common multiple, or LCM. Here we are finding the smallest positive integer that is divisible by two numbers. The least common multiple of two or more integers is the smallest positive integer that can be divided by each of the given integers without any remainder. For example, the LCM of 12 and 18 is 36, because 36 is the smallest number that both 12 and 18 divide into evenly. There's a useful formula to calculate the LCM, that is, the least common multiple of nb equals a times b divided by the greatest common divisor of nb. Let's explore the uses of least common multiple. The LCM has various practical applications. It is used in finding common time periods, working with fractions to find common denominators, solving scheduling problems, and in discrete mathematics and algorithms. Here's a real-world example. Two buses arrive at a station every 15 minutes and 25 minutes respectively. If they both depart at 9 a.m., when will they next depart together? To solve this, we find the least common multiple of 15 and 25, which is 75 minutes. Therefore, they will next depart together at 10:15 a.m. Now let's delve into prime factorization. Prime factorization is expressing a number as a product of prime numbers. For example, 60 equals 2 squared times 3 times 5. The fundamental theorem of arithmetic tells us that every integer greater than 1 has a unique prime factorization. Now let's explore the key applications of prime factorization. Prime factorization has several key applications, including the efficient calculation of greatest common divisor and least common multiple, public key cryptography such as RSA, determining the number of divisors of an integer, and solving Diophantine equations. Given prime factorizations of two numbers, for example, if a equals 60, which equals 2 squared times 3 times 5, and b equals 48, which equals 2 to the 4th power times 3, we can use prime factorization to find their GCD and LCM. To find the greatest common divisor, take the minimum power of each common prime factor. So the GCD of 60 and 48 is 2 squared times 3, which equals 12. To find the least common multiple, take the maximum power of each prime factor. So the LCM of 60 and 48 is 2 to the 4th power times 3 times 5, which equals 240. Let's explore the concept of modular arithmetic. Modular arithmetic involves clock arithmetic and remainder systems. Modular arithmetic is a system of arithmetic for integers where numbers wrap around after reaching a certain value called the modulus. We say that a is congruent to b modulum if m divides a minus b. Or equivalently, if a and b have the same remainder when divided by m. A 12-hour clock is a modulo 12 system. For instance, 10 o'clock plus 5 hours equals 3 o'clock, which can be written as 10 plus 5 is congruent to 3 modulo 12. Now let's explore the operations of modular arithmetic. In modular arithmetic, we have basic operations. For addition, a plus b mod m equals a mod m plus b mod m, all mod m. For subtraction, a minus b mod m equals a mod m minus b mod m, all mod m. For multiplication, a times b mod m equals a mod m times b mod m, all mod m. And for division, a divided by b mod m equals a times b inverse mod m, where b inverse is the modular multiplicative inverse of b modulo m. Let's take a look at some of the real-world applications of number theory. Number theory has numerous applications in the real world. These include cryptography, such as RSA and elliptic curve cryptography, computer science, including hash functions and random number generation, and error detection and correction in data transmission. RSA cryptography relies on the difficulty of factoring large composite numbers into their prime factors. Some of the key components include choosing two large prime numbers p and q, calculating which equals p times q, using Euler's totient function phi of n equals p minus 1 times q minus 1, and finding n where times is congruent to 1 modulo phi of n. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.